the two that we did on the second half of translations. The first set of translations we did moved it up and down, right? Those don't apply here. The second, the third and the fourth examples that we did shifted our graph left and right. What would we have to add in order to shift your graph to the left? Would we be adding or would we be subtracting? We'd be adding to go to the left. And what would need to be in that parentheses in order to shift it to the right? It'd be what? A negative. Okay. So now when we look at 19, parent function is this one. Remember, your parent function goes through 0, 0. That is a shift of how much? How many units? Okay. To the right, which means that if I was going to write this equation currently as it is, what value would I put inside of that parentheses? Yes, we would be putting -5. That's the equation for 19 part A. Here we are, similar. This is now P of X. This shift is to the left 6 units. So what is going to go in that parentheses up there? There we go. Any questions on this? Okay. And then for 20, it says the graph of g of x is a vertical translation 2 units up from the original parent function of x squared. Which of these are the only two that we could consider if we're looking at a vertical translation? What is it? A and C. Do these look the same in style? What does a vertical translation mean? It means that you either move up or down. That is a vertical translation, okay? Where do we add the value if we're going to shift our graph either up or down? Is it in the parentheses or outside at the end? Yeah. These right here are going to cause it to shift either left or right. So these are not possible. Okay. So the and B. But which one is going to cause the graph to move 2 units up? I hear 2 people say it. That is correct. A. Okay. All right. Let's go ahead and move on. We're moving on to 30-2. Okay. It says graph vertical stretches and shrinks of the quadratic parent function. Imagine taking your U shape, okay? Put your arms up, put them like this. I didn't say like this. I didn't say rest them. I said put them, I didn't say like this. I said make it look like a U shape from where you're at, okay? Make it look like a U shape. Thank you. Now, what happens if I were to grab your arms and stretch them up? What would happen to the U? Is it getting wider or is it getting narrower? Okay. Put your arms up. Well, because you're the closest one to me. You're always on the delay. So now we're going to stretch it. Yes. Turn around this way. You're fine. You're fine. Look. So here's the original parabola. Here's the parent function. Yes, everybody see it? Yes? And now watch, we're going to stretch it. Yes? What happened to the U shape? What happened to it? It got narrower. That is what a stretch does, okay? So go ahead and draw a regular parabola. And then when we say vertical stretch, it gets narrow, okay? So this is a vertical stretch. You can even put a little note here. It becomes more narrow, okay? Oh, shoot, I didn't record me stretching your arm. Should we do it in front of the camera? Okay, now, we also talk about a shrink. What does that do? Well, instead of me stretching it, now imagine that I'm putting weights on it. What's going to happen to your arms? Are they going to be able to keep them up like this? What's going to happen to your arms? It's going to get wider because you're squishing it in. Okay, so here's the original parent function as well. And then a vertical shrink means that it gets wider. Okay. So again, when we're talking about the stretch, remember stretching your arms upwards, it squeezes it in. The shrink, we're pressing it down so it's going to get wider out like that. Okay. This looks slightly different from the equations we did yesterday. This is still the parent function. Do we know the ordered pairs that happen in the parent function? Did we write these values over and over on the tables yesterday? So quickly look at the tables yesterday. Who's paired with the -2? Who's paired with the -2? 4. And so it's going to be 1, 0, 1, 4. You might be wondering, why does this table look slightly different? They just didn't include the -3 and the 9 or the +3 and the 9. But there's more values that I could be including if I wanted to. So now today I want to see, well, what happens to the parent function? What am I doing to the parent function now? If there's a 2 right in front of it, what does that mean? As what? I can hear you. As who? I'm not going to.
Are you sure?
Yes.
Are you sure?
Mm-hmm.
Positive.
Yeah.
All right. It's not even that nice in your class.
I know. I hate my life.
Jimmy, but he offered you a whole donut.
I know, but I can't.
Because do you have napkins?
I have. Okay. All right. Here we are. What are we going to do to our x squared according to this? What does it say mathematically? When there's a 2 out front, what does that mean? I can't, you guys are like mumbling. It's like, yes, you are multiplying by 2. So I'm going to take each value and I'm going to multiply it by 2. What's 4 times 2? 8. What's 1 times 2? 0 times 2. 1 times 2. And then 4 times 2. 8. Okay. So when I take my quadratic parent function and I multiply it by 2, look at what happened to all of our y values. They all multiplied by 2, okay? So they have done us the gracious favor of multiplying, or sorry, of graphing the parent function. We know what it looks like. We did it like 5 times yesterday, right? Now let's go through and graph the new one. The new ordered pair is -2 and 8. So how do I get to -2, 8 on this graph? How do I get to -2, 8 on this graph? So from the origin, I go 2 to. So there we are. So there's going to be the first point. What's the next ordered pair? -1 who? -1, 2. So I'm going to go to -1 and up 2. So there's the next point. What's the next ordered pair on our table? 0, 0. Then it's 1, 2. And then 2, 8. Okay. So go ahead and connect those points together. Again, it doesn't have to be perfect. Okay. So I took my parent function and I multiplied it by a whole number right here, and look at what it did to the graph. Did it spread it out or did it stretch it up? It stretched it. So let's go ahead and label this. This is what we call a vertical stretch. It got narrow. And it should make sense. The original point here was at -2, 4. We took this point and we doubled it, 8. This point right here was at -1, 1. What is that double? 2. Okay. So that is what we call a vertical stretch. Now, we already know these values from yesterday. What are the values that go in this table here in this first column? Please pre-fill them out from the tables that we did yesterday. Go back to page 4. What page is it on? It's the same first column for all of the graphs that we did. Okay, help me out. What is the vertex for our parent function? 0, 0. Okay. It's an ordered pair, so you have to list both. Even if they're both 0 or the same number, you have to list them both. Okay, so it's 0, 0. What is our domain? Negative infinity to positive infinity. What's our range? What's my range? Why what? It's not equals. What's the symbol that's there? Yes. Ready to go or just for a moment? Oh, you don't people do. Okay. Yes. Yep. Give me a second. And then our axis of symmetry is x equals 0. With the people at your table, I want you to go through the newly transformed graph, the red one, and come up with your vertex, domain, range, and then your axis of symmetry. So they give you the surface area. So here's the formula. SA equals, you'll have your formula. Where the SA is, you're going to have 8 here to plug it in there. So this is the first time where you see we have to plug something in for surface area on the left side. So you're going to plug something on both sides of the equation in your solving formula. For the 10, what's the formula for that shape? What's the formula for surface area? Okay. So for this one here, you know that this little angle here is going to be equal to 1/2 of the large angle up here, so the one across from it, the large arc, minus the, what is this, support? Yeah, arc. So you're going to take the bigger arc minus the smaller arc. They're all within view of this right here. So the arcs that are within here, so you take this arc minus this arc. So this little angle will equal 1/2 of this minus this, okay? So we need this arc, and we need this arc, and we need information for this angle. Do we have information for all three? No. You only have that one, you're missing this one. However, do they give you that other arc? What do all the arcs in circle have? 360. So you have 81 and you have 74. Okay. So we'll add those together. That's 5, that's 15. And now I just have to figure out the rest of it, what's remaining. So 180. It's 360 minus 155. So 6, we've got a 5 here, 10, 10 minus 5 is 5, 5 minus 5 is 0, 3 minus 1 is 2. So this angle over here is 205. So now I have the setup according to this. So you have the angle, right, is that correct? Equal to 1/2 times 205 minus, okay? This almost simplifies, so you're really going to have 17x minus 28 equals to whatever number that is. And then it's just a very easy, straightforward equation. You put it exactly like it is in the calculator. 1/2 parentheses and then 205 parentheses. And that's going to be just a number. Right, but they want to know what it actually equals. So you have to go through and find X and then plug it in there to say, hey, W is X, Y.
rid of that?
No, you can't, because that's part of this. So this one here is not. W is X. This one over here is 13. X Z equal X plus 36. If that is the angle is half of the arc. So what does it mean when there's a number outside of parentheses? And distributed through, okay, or, what's the opposite of could? Yeah, but here what would be easier, no, if you divide by 1/2, this won't give you, this will give you a number. Okay. How about this, multiply by 2? That's the opposite of this, so these are gonna cancel out. You'll just have this, and what's here, you'll distribute. Okay, so start there. And see if you can do something. Are you eligible to come for school for teachers? Technically, we wouldn't use y here, you would use X plus 6.
See, I'm just not truly choosing equator because I have notes that show equations, we use y as a equator multiple times, so choosing equator.
But ask your tutor, how do you solve an equation in those two variables? No, I want formula to be like with just, I want the formula to be something like this with no variables. Oh, yes, but I can't be a full hour, so it'll just be like a small fraction of time. Well, I say like 10 minutes, yeah. Okay. No, but thank you for asking. All right, so for this one here, what was the vertex? Still 0, 0, right? It's still the same ordered pair. What's the domain? It's still negative infinity to positive infinity. That is correct. Make sure you wrote that. What is going to be the range? Still going to be the same, y greater than or equal to 0. And what is going to be our axis of symmetry? It's still the exact same. Oh, by the way, that they need you in the office ready to go. Okay, so it's still going to be x equals 0. Okay. There we go. So for this, still y greater than or equal to 0 and still x equals 0. Okay, any questions there? No? So what do we notice on this table? It's the exact same thing. So does stretching a graph affect your vertex? It's still in the exact same spot. Does it affect your domain, how far out this graph is spreading? No. Does it affect where it started? The lowest that it goes? No, they both go to that same value of 0, right? If we draw our boundary, it's still at the exact same spot. And then was our axis of symmetry any different? No. So this key identifiable factors are going to stay the same. Those key features don't change for graphs whenever we stretch them. So now guess what they're saying? They're like, okay, well, on that other one, we multiplied by a whole number. What are we going to multiply by now? By a fraction. Okay, so let's go ahead and fill in our values. We already know this is 41014. Okay. And then we're going to multiply by 1/2, or essentially just find half of it. You can use your calculator. What is 4 times 1/2?
2.
2. What is 1 times 1/2? It's 0.5, or just 1/2. What is 0 times 1/2? 0. What is 1? And 4 times 1/2? 2. There we are. Okay. So now we're going to graph this one. Did they already graph the parent function for us? Yes. So let's go through and let's graph these. What's our first ordered pair? -2 and 2. So let's go through and graph that. Let's go to a -2 and 2. What's the next ordered pair? -1, but I only go up halfway. I don't go all the way up to the 1. So it's right there, halfway between 0 and 1. Right there. What's the next ordered pair? 0, 0. What's the next one after that? There, and then 2, 2. So let's go ahead and what happened to this graph? They got wider. So this is what we call a vertical shrink. Okay, a vertical shrink. Okay. All right, let's go ahead and look right here. It says identify the vertex, domain, and range. We already know these values. 0, 0, -infinity to +infinity. We know y greater than or equal to 0 and x equals 0. That's all the same from the previous one. I'm going to mark my vertex, and I'm also going to mark my axis of symmetry. Okay. With your table, come up with these guys right here. Yep. So, let's just say, for example, you have this equation right here. You're really probably not going to because that shows up as a coefficient all the time. Like that. Okay. So typically it's really simple. But I think that makes it hard. So you're going to set it equal to 0, so that means y equals 0. So we say 0 there. You have x squared plus 12x plus 32. The reason why we're considering this right is because this trinomial can't be factored like the way we did. You know, we would put x squared in this box, we would put the 32 down here, and we're just trying to guess and check what numbers multiply equal 32 and what numbers add up to equal 12. There isn't a combination, so we have to complete the square. By doing this, we first subtract the constant from both sides, so we get rid of 32. If it was a negative, it'd be adding it to the sides. So now you have -32 is equal to x squared plus 12x, and then it's in the same format as quadratic of a squared plus bx. So that's 128 out plus 3a is 3. Now, to complete the square, you have to add. That is by 2 squared to both sides. So that's how many to both sides to keep it the same balance, okay? So who is my b? It's a square. So I do 12 divided by 2 squared. This is 6 squared, and I just leave it like that. Here's why. If I put 36, then I have to do 33 again. What numbers multiply to equal 36, but add up to equal 12? 6, yes? So it's this value right here. That's why I keep it at 6 squared, because that value squared is what's going here. I'm factoring this in the trinomial to see what two things multiply to equal this trinomial. So I know that x has to go there and x has to go there. That's x times x equals x squared, right? I'm also going to get 6 times 6, which equals 36. And I'll get middle terms. It'll be x times 6, and then 6 times x. 12x. But now, because these are identical, I'm going to write it as 4 equals. I have the 6 over here, and you can choose 6. This can just be rewritten as a 34 squared. And then I want to have a 0 back here again. Subtract by both outside, and now I have it in. Okay. And remember, this right here, this h and this k are your vertex. So if you were to graph this, you would see that our vertex is at -6 and -5. This one goes by the opposite. If you're going to negative it, then you do positive. Yes? All right, what do we got? Thank you. Yes, hurry up and go. Okay, what is it? It's who? The audacity. You mean I walked away and that's all we came up with, that it's all the same? Yes, that is correct. Okay. Did you not trust your partner? I mean, I wouldn't trust me. Okay. Let's see here. So describe any patterns that you noticed. Let's describe the patterns that we noticed on the tables. What patterns did we notice? Huh? The information doesn't change. Okay. What about on the graphs? What happened on the first graph when we multiplied by a whole number? It got narrower. What happened to the equation when I multiplied by a fraction? It got wider. Good. So it's telling us here that the change to a parent function is called a vertical stretch. That's what we did on the first one when we multiplied by a factor of 2. And on the second one, it's called a vertical shrink when we multiplied by a fraction. So it's saying, hey, whenever we have positive values, meaning values that are greater than 0, okay, how does that first value being multiplied by your x squared change your parent function? Well, here's what we're going to say. If a is greater than or equal to 1, meaning a whole number or anything larger than it, we're going to say the parent function will vertically stretch. So we will go ahead and say it becomes narrow. Okay. Now, if I'm going to go ahead and say a is greater than 0, so it still has to be positive, but it has to be less than 1. So if it's a fraction between 0 and 1, any fraction, meaning any decimal value between 0 and 1, the parent function will vertically shrink. So let's go ahead and say it gets wider. Cuestiones? No? Let's see, what else do we want to do? I want you to work on right now numbers 7 through 12. You have plenty of time, okay? Here, they want you to predict, first of all, what's going to happen to it just by looking at the equation, right? This one was multiplied by 3, so what do we think is going to happen there? We have examples. This one's going to multiply by 1/4. What do we think is going to happen? So write your prediction and then use your calculator to graph it to see what actually happened to it. But what should you be comparing this graph to? Which one are we always comparing it to? The parent function of x squared. So when you go to graph these to double check your prediction, make sure you put the parent function first on f1 of x, and that you put this one on f2 of x, okay? That way you can see what happens to it. 9 and 10, they're saying, hey, if you're going to vertically stretch your graph by a factor of 5, how are you going to rewrite the equation? What happens if you're going to vertically shrink it by a factor of 1/5? So are you doing any crazy calculations for any of this? No. You're just rewriting equations here. You're going to predict, and then you're going to graph to double check. And then here, it gives you a scenario of a vertical stretch. It wants to know which one is the correct one. Yes? Here for A, B, and C, and D, I want you to tell me what happens. Does it get narrow or wider? Okay? Okay, go ahead and go. You can answer them right there on that same page.